Okay, in this section we're going to talk about how to find the mean, the variance and the standard deviation for the binomial distribution. So it's actually a little bit more simple than for any regular probability distribution. If you recall, we had to use a pretty crazy formula for that. In this case, it's going to be more simplified. Let's start out with the example here, though. Suppose you flip an unfair coin 5 times, unfair coin, 5 times. This particular coin has a probability of 0.6 of landing on its head. That means 0.4 on tails. Find the probability of getting 0 heads, of getting 1 heads, 2, 3, 4, 5 heads. And so if you do that calculation using this formula, right, it's a binomial. You either get heads or tails, and you have the same probability every single trial. So if you use this formula for n is equal to 5, and then x keeps changing, 0, 1, 2, 3, 4, 5, and so forth, the probability p is going to be 0.6, the q, the probability of failure, is going to be 0.4, and you would get these probabilities. This should add up to 1 if this is a probability distribution, okay? So that right there is using the formula. You can also recreate this using the calculator and so forth, but the question then would be, well, what's the average amount of times that I should get a heads if this is an unfair coin? And the way that we previously have done this is we multiplied 0 times its probability, 1 times its probability, 2 times its probability, 3 times its probability, and so forth, and then added up all of the results, and then we got the mean, the average. Well, in this case, actually, because it's a binomial situation, you don't have to do that. The mean is actually given by the number of trials times the probability of a success on each trial. Instead of using this formula right here to find the mean, the average amount of heads, you can use this formula, n, which is the number of trials, 5 in our case, times p, which is 0.60 or 0.6, and that would give you the average amount of trials, which 5 times 0.6 is 3. And you can guess 3 is almost dead center right here, right? The average you should get or expect would be 3 heads among 5 coin tosses. So there is simplification that can happen when you recognize that you're dealing with a binomial case, okay? So keep that in mind when you're doing your exercises. Ask yourself, is this probability that I'm looking for, that I'm being asked to look for, is this from a binomial situation or not? Same thing with the standard deviation. If you recall, there was a pretty crazy formula that we had to fill out for the standard deviation, but it simplifies to the square root of NPQ, and that's it. The standard deviation is square root of NPQ for any binomial distribution. And so you can use these two formulas to answer questions like this. Suppose you flip an unfair coin 8 times. The probability that the coin lands on heads is 0.3. Find the mean number of heads expected and the standard deviation of the probability distribution. So 8 and 0.3, I have those. Let's use those. So we have n is equal to 8, p is equal to 0.3, and q therefore is 1 minus 0.3 or 0.7. Now to find the mean, the formula is n times p, which in our case is 8 times 0.3, right? That's 2.4 heads. You can round that, or leave it b if you want to round to one more extra decimal place. Remember the rounding rules. And then the standard deviation is the square root of NPQ, and in our case, the square root of 8 times 0.3 times 0.7, a little bit more math that we would have to do. But if you do that, 8 times 0.3 times 0.7 would get you 1.68, and then the square root of 1.68 then would be your standard deviation. Okay, and if you find out the square root, you can use that on your calculator, and you get approximately 1.296. I should say approximately. Now it's your standard deviation. That's it. That's how you find your mean and standard deviation when you have a binomial case. Awesome. Here's another point to make sure you remember. Most values of our probability distribution will fall within 2 standard deviations of the mean. The maximum usual value is mu plus 2 sigma, or mu minus 2 sigma is the minimum value. So keep that in mind, largest, smallest values. Mars Inc., here's another example, claims that 16% of its M&Ms are green. A sample of 100 M&Ms is randomly selected. Find the mean and standard deviation for the number of green M&Ms in such a group of 100. Okay, so let's figure this out. We are given that n is equal to 100. And then the probability is going to be equal to 16%, right? They said 16.16. That means Q, 1 minus that would be 0.84, right? And we would need to find the mean. So the mean is equal to n times p, or 100 times 0.16, which is 16. So we should expect 16 green M&Ms in any one bag. Standard deviation, the amount of green M&Ms on average would deviate by this amount. Square root of npq would give us square root of 100 times 0.16 times 0.84, like that. And when we multiply that out, we would have 100 times 0.16 times 0.84 would be 0.13. So, 13.44, and the square root of that would be 3.666. So approximately 3.666. So the number of deviations, or the green M&Ms could deviate by 3.66, or approximately 4, above the mean or below the mean. That's it for part A, or for the first part. So find the mean, standard deviation, and the standard deviation. The mean is 16, the standard deviation is 3.67 or 3.666. Suppose we did our own sample of 100 M&Ms and found only 8 green M&Ms. Is this an unusual value? Well, according to the previous slide, we have to calculate 2 standard deviations. Here's what that looks like. So if we calculate here that the mean is 16, so the mean is 16, and our standard deviation is 3.66, then I would need to add 2 standard deviations above and below the mean. So 16 plus 3.666 would be 19.666. If I add 3.666 to that, I get 23.332. Below, 16 minus 3.666 would be 12.334. And if I subtract 3.666 one more time for another standard deviation, I get 8.668, like that. So here are 2 standard deviations away from the mean, right? Here's the mean, and then 2 standard deviations to the left and to the right. And the question is, we got 8. Where is 8? 8 would be right here. And so is that outside of or inside of 2 standard deviations? That is outside of 2 standard deviations, so that is an unusual amount. 8 is outside of 2 standard deviations from the mean, and therefore an unusual amount. Okay? I hope that this helps and that this is clear for you guys. Next video, we're going to start looking at continuous probability distributions.